All right, welcome to section 6.6, solving exponential and log functions. All right, like we always do, we always go over what we're going to learn. We're going to learn how to solve exponential equations, and we're going to learn how to solve log equations. Okay, so two different types of equations, one with exponential functions, one with log functions. So what are these exponential equations and log equations? Exponential equations are equations in which the variables occur as an exponent. Okay, so any sort of an equation where the variables in the exponent. So for instance, 3 raised to the x power equals 6 is an exponential equation. It has an equal sign and the variables in the exponent. Okay, a log equation is an equation that involves logarithms of variable expressions. So for instance, if you have a log with a variable in it and it's equal some number. Now these could come in different forms, but this is just one example of what a log equation would be. It has a variable inside the log. All right, so the only way to learn these is doing a bunch of examples. So let's start off with examples of exponentials. All right, so example 1, solve. The hint here, okay, I'll give you a hint, get the same base. Okay, so we're going to look at the numbers that they give us, and we're going to come up with numbers that are the same base. All right, so I'm looking at, I have 81 and I have 9. Okay, is there any way to turn both of these numbers into the same base? I hope you see that there is. I can turn 81 into 9 by doing 9 squared, and I can't forget this x. The x is still there, and now I have two numbers with the base of 9. Okay, so this right here, I'm going to do my product of properties. So I have 9 to the 2x equals 9 to the x plus 4, and now the problem is very easy. Once you have the same base, okay, once you have the same base, the problem becomes very easy because all you do is set the two exponents equal to each other and then you solve. Okay, so I'm just going to say now my exponent on the left is 2x equals x plus 4, because the base is already the same. I don't need to worry about those anymore, but I do need to figure out what x is. Okay, so I subtract x, x's go away. 2x minus 1x is 1x equals 4. So for this problem, I solved x is equal to 4. Okay. All right. The second one's a little bit harder. Okay. Second one's a little bit harder. Same steps though. How do I get the same base from 100 and 1 over 10? Okay. So let's think about it. I see 10. I see 100. I can probably turn these into a base of 10. So 10 squared is 100. I still have that x there. And now let's not forget our exponent rules. How would I turn this into a 10? Would you agree that 10 to the negative first power is 1 over 10? I hope you would. Okay, and I still have this x minus 3 out here. All right, so now we need to multiply our exponents. So I have 10 to the 2x equals, and then now I have a 10. I have to multiply this as well. Negative 1 times x is negative x. Negative 1 times negative 3 is positive 3. All right, so now I have the same base, we can now set them equal to each other. So 2x equals negative x plus 3. And now we're going to solve this. So I'm going to add x. So now I have 3x equals 3, and I can divide by 3, x is equal to 1. Okay, so our goal is to get the same base on both sides and then set the exponents equal to each other. All right, so part 1, we're still solving exponentials, and now it's going to look a little different. We're going to have an exponent on one side and then a whole number on the other side. Okay, and the hint for this one is to log both sides. We're going to log both sides. All right, so let's see what I mean by that. Our goal is we're trying to solve for x, so somehow I need to get rid of this 2. So if you notice here, I'm going to take log base 2 of both sides. Okay, and it's an equation, so whatever I do to the left, I have to do to the right, and I can do whatever I want to the equation as long as I do it to the left and the right. So now, why would I do this? Okay, and so from last couple sections here, we see that log base 2 of 2. Remember that cancels, and I'm left with x on the left equals log base 2 of 7. Okay, and then now x is equal to log base 2 of 7. This is a pretty easy calculator problem now because of last section. We learned the change of base formula. And what did the change of base formula say? That you can take log of the number next to the log, divide that by log of the base, which is 2, and that will give me my answer for this. So I just go to my calculator, get rid of this, And let's do log of 7. Log of 7, close your parentheses, divided by log of 2, close the parentheses, and it should equal 2.807. So x is equal to 2.807. And there you have it. Okay, so let's do one more example here of this type, and then we'll move on to type 2. All right, so now I need to get rid of a 3. So I'm going to take log base 3 of both sides. So log base 3 of 8. Okay, on the left here, the log base 3 of 3 cancels. I'm left with x minus 2 equals log base 3 of 8. All right, and then last but not least, how do I get rid of the minus 2? I'm going to add 2 to both sides. 2's go away, so I'm left with x is equal to log base 3 of 8, and we just learned that I can do change of base. So that's log of 8 divided by log of the base, and at the end of that I'm going to add 2 to it, and that should be my answer. Okay, so let's go back to the calculator, delete what's there. I'm going to do log of 8 divided by log of 3. I'm going to hit enter, and then I'm going to add this 2 to the end of it, so plus 2. And that should equal 3.89, 3.89. All right, so x equals 3.89, and then we are done. All right, so part 1, example 2, so we're going to log both sides again. This is the same type of problem. This one's just a little bit harder, so we need a little bit more room to do this one. All right, so now here's the issue. You have to get this part here, the exponential part, by itself first. So I need to get rid of the 7, I need to get rid of the 4. So what I'm going to do first is I'm going to add 7 to both sides to get rid of the 7's. So I have 4e to the negative 0.3x is equal to 20. And now I need to get rid of that times 4. So I'm going to divide everything by 4, divide by 4. So e to the negative 0.3x is equal to 5. Okay, now I'm going to take that problem and I'm now going to log both sides because my exponential part's by itself. All right, so log both sides. Well, the problem is it's not a number anymore, it's e. So instead of doing log of some base, you do ln because ln is base e. So I'm going to do ln of e to the negative 0.3x equals ln of 5. Notice now that ln of e goes away. I'm left with negative 0.3x is equal to ln of 5. And then last but not least, I'm going to get the x by itself, so I'm going to divide by negative 0.3. And x is equal to ln of 5 divided by negative 0.3. And that's simply a calculator problem. So clear everything out. ln of 5 divided by negative 0.3. Hit enter. My answer is negative 5.36. Negative 5.36. Negative point. Oops. Forgot what it was. Negative 5.36. So we erase this, negative 5.36, and there is our solution. So if the exponent's not by itself, you just have to extract everything that's attached to it and then do the log both sides. Okay, so last but not least, we have part 2. Okay, part 2 is where we're going to solve log equations and example 1. So the hint for this one is raise to the both sides. Okay. So once again, our goal here is to get x by itself. Okay? Well, it's attached to the ln. I can't get rid of that if I don't have something to cancel it with. So what I'm going to do is I'm going to raise the whole problem from e on both sides. And that seems silly, but I'm doing whatever I want to the equation as long as I do it to both sides. So the e's and ln cancel. I'm now left with 4x minus 7 equals x plus 5. And now I can solve this. Okay? So let's add 7. So 4x equals x plus 12. Okay, now I can get the x over there, so subtract x. So 4x take away 1x is 3x equals 12. Divide by 3, x is equal to 4. 12 divided by 3. Okay, so very simple, not a hard problem. We're going to do the same thing on this one, except the log, there's only one log on the one side. We do this the exact same way. We need to cancel log base 2, so I'm going to take both sides and make it a base of 2. So 2 raised to the log base 2 goes away. I'm left with 5x minus 17, and that's equal to 2 to the third power. 2 times 2 times 2, which is 8. And then now we just solve this. So plus 17 plus 17. So 5x equals 25. Divide by 5. Divide by 5. X is equal to 5. Okay, so slightly different, not very hard. Just raise to the on both sides. Okay, I raised to the e on this one, raised to the 2 on this one. That gave us our answers. Okay, and last but not least, we're gonna save this example for in class. So we're gonna wait till we get to class to do this one. If you want to look in your book to kind of see how it goes, please do. But it's the same exact thing. But we need to use our, I'll give you a little hint, we need to use our log properties first. Okay, we need to use our log properties first to get one log happening here. Okay, so remember, the plus really means multiply. Okay, so we'll save this one for class. It's a little bit harder, and I will see you tomorrow.